right, I think we'll get started here in just a moment. As we get going, there's kind of a few logistics I'm going to talk through. There's a couple resources I'll share as well. This workshop is going to be a combination of some slideware from my side, but hopefully not too many. There will also be a notebook and some other resources I share as well. So just as a quick note, as we get started here, we're going to be spending about the next hour talking about interacting with and building off of the 51 Tools plugin ecosystem. This is meant to be kind of a combination of presentation and hands-on. So you see an initial title slide here. There'll be some slideware as I talk through concepts. Like I said before, there will also be a notebook that I share. And then there's going to be as I'll be walking through the content and the demos as well. Couple things this workshop presumes is it does not begin with like a 51 101 workshop. That's a lot of numbers. Basically, there's going to be kind of a base level assumption that maybe you've been exposed to the 51 platform before. Now, again, the way this is written is it should be accessible for those that might be new. But at the same time, if you have used 51, we're going to be building on top of it. So the goal is hopefully maybe you have a little bit of that background already. And then we're going to talk about, okay, as you kind of start building your workflows, what does it look like to use the plugin ecosystem, the operator ecosystem? We'll start working in skills and agents as well. On top of that, this is not really a computer vision 101 or like a Python 101 course. Again, really the goal is to think about using the 51 tool as a building substrate for our workflows and other tooling. But that being said, we're going to be using 51 to load data sets, build plugins, and so forth. So I think with that said, I think we're okay. We'll get going here. One last thing as well, couple ways that folks can interact. I believe most folks are on the call in what's called listen only mode. I can see obviously the chat is accessible. If you have like specific content related questions, if you go to that more kind of three dots bottom on your Zoom toolbar, there's a section called Q&A. If you're able to use that to submit specific questions, that will be the most ideal. It's just easier to keep track of what's been answered and not answered. But we will be engaged in the chat as well. Again, it hasn't been a major issue with these workshops up to this point. Okay, enough yapping from me. Well, actually, we're just getting started with the yapping from me, but I'll go ahead and proceed to the next slides. So the way to think about 51 is we're going to be approaching this in layers, starting with what we call kind of the mental model of what we're building. And I really want to begin with a little bit of an analogy. So one way to think about 51 is it's a tool to build computer vision, data sets, workflows, model training and evaluation. It's an extremely flexible platform. So if you've used 51 as software before, you've probably noticed that a great deal of the interaction with it is programmatic. And again, I'll give kind of another introduction to 51 here in a moment for those that might be new, but you've probably noticed that the way you interact 51 is largely through the SDK, and it's an extremely programmable interface. And the analogy I like to give is a lot of pieces of software, particularly SaaS tools, right? 51 isn't SaaS, but especially SaaS tools, though it's not limited to that, is like imagine that you are shopping at a store and you're going through like the Lego aisle to pick up Legos for your kid, your niece, your nephew, or often for me, myself. And when you buy Legos, there's often a couple ways you could do so. Way number one is you have like the pre-built Lego kit to build the exact thing, right? The Empire State Building, the Millennium Falcon, the Statue of Liberty, Golden Gate Bridge. Insert thing here. And it gives you the instructions and it gives you the exact pieces to build it a very opinionated way. Another way you can buy Lego is there's like the 10-gallon bucket often found on like the bottom shelf that contains every Lego piece in every color you can possibly think of. For me growing up, that's largely like what I got or my parents got me. I would get that 10-gallon bucket and I would like dump it on my bedroom floor and I would like build whatever I want, right? I would build a Empire State Building sort of replica with a spaceship taking off from it. And I liked the pre-built kits, but ultimately those would, end up as things that would end up on my bookshelf if, once it's made. But the actual giant 10-gallon bucket I found to be a lot of fun. 51 as a platform, in a lot of ways, is intended to be that 10-gallon bucket, right? Include many powerful features, have ways that are straightforward to use them out of the box, but also give you the flexibility really to build whatever you want in a way that works for you and your team. So 51, by its design, is an extremely pluggable interface. Now, ultimately, what 51 um, is it is a platform for building machine learning data sets, primarily visual data sets. So if I can type and talk at the same time, and I go to my, whoops, looks like it already. Give me 1 second here to reset. Actually, I'll do this in the lab. I'll do this in the lab here in a moment. Let me go here instead. So 51 as an interface is ultimately, and I'm signed out. All right. We're off to a great start here. Um, I promise I have a data set loaded up here. All right. Third time's the charm. 51 ultimately looks like this. This is the visual way you interact with it. So this is using just a subset of the Cocoa dataset called Quick Start. And again, if you've used 51 before, you'll be familiar with this interface. So we have the sample grid here. We have ways of filtering data. We have all these operations we can perform on data. We have panels that we can open up to view things like embeddings and view it alongside our data. And ultimately, what we're going to talk about is the construction of these resources. So again, 51 gives you all these capabilities out of the box in terms of loading in computer vision data sets, analyzing the data, filtering and querying, as of the last couple months, annotating, generating embeddings, generating and analyzing model evals. But ultimately, these panels and these operations is actually what we call a composable interface. And intuitively we can kind of see that, right? We can see that like, oh look, this is a panel that's like a container within the app. Well, ultimately these are things we can build. And yes, these ship out of the box with it, but we're not restricted to just the panels provided here or just the operators provided here. We can build our own. And ultimately that is the goal of today's workshop. So a quick note about setup. The resources of this workshop, the slides, the notebook, the recording, these will all be provided to you after the workshop is over. If you want to follow along, um, these are kind of some base getting started instructions. This QR code links you to a Colab notebook that contains the workshop material. I always give the disclaimer, let me know if the QR code seems to have like any kind of problems. Um, and I'll throw the link directly into chat, but this should link to the Colab notebook. And then um, this is how you install the 51 package and then the Open Clip Torch for generating embeddings as well as part of the notebook. Now, I hosted the notebook in Colab. It's ultimately meant to be able for you to download and use yourself as well. So give me 1 second here. All right. So 51 is ultimately a pip installable package. Pip install 51. It's in PyPy. Thanks, Burhan, for pasting the Colab link as well. Let me just triple check it is the right one. I can see it's loading, but I think it is. All right. Oh, you know what? I'm sorry. Let me verify the notebook real quick. It might be the wrong link. That's the QR code. Let me triple check here. Okay, folks, I apologize. I thought I updated the QR code. Give me 1 second here. This is a sort of initial, let's make sure we do this correctly sort of thing. All right, bear with me 1 second. I'll make sure it's correct here in a second. I made a couple updates last minute to the notebook file. Worst comes to worst, I'll put the direct one in chat here in a moment. So I apologize, not trying to confuse people, but we'll get it fixed here in just a moment. Let me just verify because I'm seeing a reference to something that I removed, which is not a huge issue, but I want to make sure the flow is correct. All right. Okay, I'm seeing a reference to an annotation thing that is no longer included. All right. All right, I'll proceed here for just a minute. We're not going to be in the notebook quite yet. And then again, I'll share the right link here in a moment. And you'll definitely get the right link after the workshop. But again, it would be great for folks to watch and follow. All right. So again, we're going to start with a few concepts here. And I want to start with kind of the mental model of what we're talking about when we are referring to um, right. All right. So ultimately, 51 as a platform is constructed like the following. So again, we have the core dataset SDK backed by MongoDB for metadata storage, and then local file storage is used for unstructured media, images, videos, so forth, if you're on a local system, and an object storage if you're on like the 51 enterprise cloud deployment. And then what we call the pluggable pieces are this brain annotation backends, model zoo backend, and then skills and agents and plugins. So these are what we call kind of like the pluggable things you can build off of. So 51 Brain, the annotation backend, the model zoo, these are direct data interfaces. So 51 Brain are the algorithms you can run to run things like similarity indexes, uniqueness indexes, embeddings, computing like model evaluation. Those are algorithms you can swap off from the defaults to bring in your own to perform to decide, hey, what are things like the default embeddings computation? You can directly connect 51 to things like a model zoo or dataset zoo or remote dataset and model sources to source models from. You can connect 51 to either like the default annotation or another backend. Um, all right. And then on the top here is especially where we build on top of. So the 51 plugins are arbitrary ways you can extend 51, arbitrary ways you can interact with the 51 SDK, both programmatically and also building containers into the app itself. And we'll actually do an example here in the notebook, which I just figured out what the problem is, by the way. And I'll give you the corrected link here in a moment. Um, and yeah. Um, And then skills and agents are using LLMs and coding harnesses and those associated tools to interact with 51 using your agent of choice. So 51 now has a increasingly mature skills library, MCP server, which I'll demo here in a little bit, as well as now in the app, in the enterprise version, like an agentic UI panel that opens up, which allows you to interact with and ask a local agent to do something like analyze my data sets, perform these operations, and you can see the tool calls. And it's actually a really nice way to kind of onboard onto 51 as well. So we'll go through all of that here. All right. So here's what we're going to build. And again, this is where I'll paste in the corrected notebook here in a moment. Some of these we'll do directly in the workshop. A few of these are going to be left as an exercise for the reader. The key thing is going to be what we're going to call creatively, I call it a composable curate plugin. Basically, it's going to be a plugin that uses an operator that gets exposed as a panel that gives you like core metrics about your data set distribution, and then also gives you an interactable way to find outliers in your data set. And that'll touch on the plugin interface, the operator interface, and then building a custom panel as well. And then also, this will be again left as an exercise to a reader. There's also stuff in the notebook, which I'll also talk through and demo a little bit around interacting with coding agents and MCP and skills as well. Okay, give me a moment here. I think I fixed the notebook problem, and I will share the corrected link here in just a moment. Again, apologies about that. This is the thing about version management with Jupyter Notebooks. Give me 1 second here. Oh, I see what happened. Yep, yeah, I'm wrong version. There we go. Right. And again, I'll make sure the QR code gets updated in the resources we send out as well. Okay, it is now correct. Let me verify it's accessible. And then again, I'll share here in chat. Right. All right, hopefully that is available to everyone. Sorry, give me 1 second here. I want the collab link. Triple checking, triple checking. Okay. All right. Sorry about that, folks. All right. Again, in terms of runnability directly within Colab, that's going to be dependent on the back end you use. It is really meant to be a downloadable notebook that uses a local 51 install. So just be aware about that. Again, I have it up locally right here, and you'll still see me run through it as well. It's not supposed to be too crazy in terms of like resource requirements. Again, we do generate embeddings like once or twice to compute a custom similarity index, but it's on a really small data set. It's just on a 200 image sample data set. So this shouldn't be too crazy in terms of that. Sorry, folks, I shared it with hosts and panelists by mistake and not everybody. Let me now share with everyone. All right, there we go. Cool. Okay, so just to get started in the notebook here, I have it up just in my local Jupyter Notebook interface. And what I'm going to start with is just making sure that 51 is active and accessible. So I'm going to start by importing my 51 libraries. I'm going to import 51. I'm going to import 51 Brain, the operators, the plugin library. And again, these are what we use to actually build off of. And then ultimately, I'm just going to verify that they're reachable. So again, if this is not um, if you don't have 51 installed already, this would be the first step. I have 51 installed, so it should already be there unless I'm using like a new virtual environment. And then we can see here's 51. Here's the plugins directory. We're on 51 1.16 in this example. And then all I'm going to do first is I'm going to load the quick start data set. So I'm going to use this method, loads you data set quick start. This is very much 51 101. How do I get started with a data set? For me, again, I'm cheating a bit. I already have it downloaded. But if it wasn't downloaded yet, it'll pull this Cocoa subset from the dataset zoo and load it locally. And then all I'm going to do is, hopefully this will work in line here, is I will load the 51 app directly within my notebook here, which it is. Here I see the quick start data set, same one I showed a little bit ago. It has 200 samples. There's by default a ground truth and predictions field. I can toggle these on or off. And then again, part of our goal here is to build off of this and do things like create a custom panel and operator to interact with this data. And then the last thing I'm going to do real quick is, because this becomes really important when it comes to how you're working with subsets and slices of your data, is using and creating views. So you'll notice that here we have the whole data set in the sample grid. You can, based off a collection of filters, you can create what's called saved views and then go to that view and then interact with them in some way. So just as a quick smoke test here, I am going to create a simple view of high confidence labels. So this is going to show predictions that have a confidence of greater than 0.9, and then render a view of that. And we can see that's what got rendered up here. So it looks like out of the data set, there are 10 samples with predictions that have bounding box predictions with at least that level of confidence. And notice we created this, what's called this stage up here. And that's actually the first thing that I want to talk about. So when it comes to kind of the foundation on how you might build things in 51, oops, sorry, my screen got a little messed up there. Let's try again. There we go. I have a screen off to the side to make sure my view looks okay. Starting with the foundation, let's start with the concept of a view. And the way that we can think of a view is it's like a query plan. So it's not making copies of your data. Again, I don't know why it's doing that again. There we go. It's not making copies of your data, but it's creating a stage of a slice of your data according to some filterable criteria. So for the example, what we just did is we looked at high confidence predictions. In this example, it's going further and it's sorting by uniqueness. So assuming we have some kind of uniqueness index, it'll show those predictions sorted by uniqueness and then render the results in a view. And then on top of that, you could either save it as a view stage, so it's a reproducible, persistent slice of data. You could also tag them. So there's tags you can do in 51, and then you could, filter by a certain tag. Maybe these need review, maybe they're tagged as edge cases, something like that. But again, this isn't creating a copy of your data set. It's just creating, additional metadata that you can use to sort and filter. Now, why does this matter? It matters because a common task for something you build on top of 51 is creating or swapping session views, basically swapping around slices without making copies of the data. So it allows for very deep interaction with the data programmatically using operators or filterable criteria you can embed in a panel. So it makes the interaction between your data set very fast. Let's now talk about the brain and annotation backends. So again, part of the core kind of algorithmic interfaces you can use is using either the default ways that the 51 brain algorithms or the annotation features interact with other services, or you could swap in your own services. So ultimately, the way 51 uses this under a hood is it's just a dictionary that maps a name to a config class. So for example, if you look at the at the similarity backends used for compute similarity, here we're passing in a backend called, sklearn, or we could use qdrant. And ultimately, we're mapping these to a specific backend config that gets passed in when you actually call the relevant 51 method, like compute similarity, for example. And all it really you need to do, and we'll do this in the notebook, is you're just, again, adding one entry to the dictionary, which we'll do in, I think, like section 4 of the notebook. Um, yeah. And then similarly, it's the same idea for annotation as well. So I don't actually include a code example here, but I don't know why this keeps cutting off. It's the same thing for annotation where, you could use 51's native annotation or you can plug it into, CVAD or Label Studio or something like that. So again, those are like the core algorithms that you can swap in or out. Now let's talk about the plugin ecosystem. So a plugin is just packaging some kind of server-side compute into a directory that 51 can use. Um, so basically, it's some sort of process that gets invoked. It could be an operator, it could be a panel, it could be a combination of both. And then that gets packaged into a local folder or directory. And then 51 will discover that directory at startup. It's really just extra Python code that 51 knows how to use if you organize it and coding it into a way that the plugin SDK expects. So, for example, the core anatomy of a plugin includes what we call a manifest and an entry point. A manifest is just a YAML file, um, generally called something like, actually always called 51.yaml. That's in the root of the plugin directory. And then you give it a name. So we'll call ours composable curate. You'll give it like a semantic versioning generally. You'll assign it to like a 51 version. And then you'll define one or more operators that the plugin can use or invoke. And then when the plugin actually gets invoked and registered, there's then an init.py, which imports the classes that you're actually using to define your operators and then registers them in a register function. Um, and again, 51 will auto discover this next time it starts if it's in the plugin directory. So the core, like the plugin itself, we can think of as like organizing compute tasks. The compute tasks themselves will be organized as Python classes, which we call operators using the 51 operator library. Again, we'll do an example of this here in just a little bit. So the operators themselves are where the heavy lifting happens. So the idea of an operator is it's a server-side function with inputs and outputs. So this example is an operator that we are calling find outliers. And then some of the methods that matter here include config, in which we give it a name or give it kind of a name and a description. This resolve input is declaring a form that will render in 51. We'll see that here. So when we actually invoke the operator, there'll be a top level form that appears. And then the execute function is actually going to do the server side work. And again, the goal here is reusable processes that you could run wherever 51 lives, and you're not necessarily like, just something that it might not be something that is just like a one-off script local to your computer. You're actually packaging it as a reusable routine. So there's the plugin, which is kind of the overall logistical organization. A plugin can call one or more operators as the actual server-side compute. And then the panels are the UI elements that you can create as custom panels in the UI. They can also be invoked by plugins, and they themselves can call operators. So the panel will appear as a tab in the UI, and that can call operators or display any type of kind of arbitrary 51 data that you might want to include. Okay, so in this example, we'll create this panel called curation dashboard. And here, this is going to invoke and load in 51 attributes like the number of, like your class distribution in your data set in this example. Um, and then it's kind of hard to see here. There's a little button, but there's a button that says find outliers. And this will actually invoke one of the operators that we've defined, which will be that find outliers operator, also rendered in the panel. And we can see here that it's calling this operator that we've previously defined in that button. All right. So let's go back to the notebook here and let's kind of piece these pieces together. So the first thing we are going to do is we are going to define our manifest. Again, this is the overall organization of the plugin. Remember, a plugin is just a directory that lives in the plugins directory. It contains a 51.yaml and it calls operators. And these can include dedicated server-side compute. It could also include panels that render as well. So what this is going to do is this is just going to define and write this plugin directory. It's also going to define uh, a few operators as well. So again, this is all just kind of like a notebook cell that will write locally, and it's going to write the manifest. It's going to write this operators.py that'll define this find outliers operator, and it'll also write this panel py variable that it will save as panel.py. And then finally, it'll write that entry point init.py as well. So just again, these are just writing to my local disk. And it created ultimately a directory that contains these resources. And then I'm just going to test that these plugins can be loaded and discovered. And by calling this operator exists, it returns true. So 51 is able to discover these. And then I'm going to kind of test this in a couple incremental ways. Method number one is I'm going to test that the operator can be directly invoked by programmatically. So before I kind of see whether it's loading properly in the UI, I'll just test to see, okay, if I directly call this operator, like, can I successfully do so? And we can see it seems to be working. It's running computing embeddings because again, it's looking to find outliers. And then based off the default value that I included, so a K value of 10, it tagged 8 as outliers. And then let's see, okay, can we get it to load successfully in the UI? So like if it tagged these outliers, can we load this view in the UI? And again, we haven't used the panel yet, but we're seeing whether the outliers can successfully be presented in the UI. And we can see it looks like they have. So these are, again, just according to whatever algorithm we used, these are what is considered to be outliers. And again, we have this view stage set up here. Now, again, this was run kind of programmatically and programmatically. Again, part of the goal here is to abstract that away and having a method in the UI we can use. So going back up here, we're now going to test to see, okay, was this panel created as well that contains a button that we can use to invoke the same operator we created? So what I'm going to do is I'm going to reset my view stage here. And I'm going to click this plus button. And I see under custom, there's this new panel created called curation dashboard. And what I'm going to do is I'm going to kind of put it side by side with my data here. Again, there's a little bit of screen real estate, but you can hopefully see the idea. I see my panels here on the left. I don't know why this is kind of flashing around a bit. I think there's a reload happening. We can see this panel on the right. We see two, and we can see that there's some like core data set attributes shown here. Again, sorry, don't know why it's flashing here, but we can see the class balance. And what we can also do is we now have this field and this button that says, hey, do we want to find outliers? And then we can run the outliers operator that we ran programmatically before, and that created the view stage, but now we can do it in the panel as well. So if I click this find outliers button, notice it now produces this form. And you might remember I defined this earlier in my plugin description, right? If I go back up here, I created the operator, I created the button, or sorry, I created the panel, and that panel creates the button that calls the operator alongside the other like data set summary attributes that are just by default being rendered there. So going back down, if I go ahead and say, hey, I want to create a view of 10 outliers and tag them with outlier, I also have the option to recompute the uniqueness as well. This should hopefully take just a moment. We can see, let me close out of here. We can now see these 10 here that, again, according to what I just invoked, is the exact same operator that I did earlier, just being run within the UI instead. So this shows those three elements, right? The plugin directory followed by, let me, again, looks like my screen got cut off again, followed by the operator definitions in Python, followed by the panel definition, are all kind of working together for me to extend the FiftyOne interface to basically just have the interactivity that I want, including custom buttons. And I don't know why this keeps happening. Let me reshare again. Once again, so much of like the out of the box. Let me try one last thing here. Yeah. Looks like it's better. Once again, so much of the out of the box capabilities, and I know there's a little bit of overlap here. I'll fix this here in a moment when I go back to my slides, is uh, these panels are created largely the same way. So for example, the model eval panel, which you can use to run model evaluations. And I know this is cut off. I'll reset it here in a moment. These are also like built fundamentally the same way. You define a panel, you define buttons, and those buttons invoke operators. Now here, this is like a gated enterprise version, but if I was running this in the enterprise version in the app, it's fundamentally invoked the same way. All right, let me go ahead and drop back over here. Okay, remember I said before that those methods we used, like using what's called the FiftyOne brain library to compute embeddings, um, they allow for pluggable backends that you can swap in, libraries or algorithmic techniques when you ultimately invoke that method. On top of that, FiftyOne also has a concept called delegated execution. So you'll notice that when I ran that button to compute the find outliers, that it ran in the foreground, right? In FiftyOne, that's not strictly required. You can also delegate job to some kind of background compute as well, so it runs in the background instead of taking up your server UI process in the foreground. So one example of a custom brain similarity backend looks something like this. So what this is showing is a config, which is defining similarity and how to add and query vectors. And the idea is this, if we can like implement this over any kind of vector store, we're telling FiftyOne how to drive it if needed. And then on the right is the actual registration. So we're defining this custom similarity backend we built and how it gets used. And then if we're calling compute similarity, we pass in a model. We're then defining this NumPy backend that we previously set up here on the left. So if I go back to my notebook here, we're going to do the same thing. So far, we can see a few of the brain backends include sklearn, Qdrant, and then MongoDB, which is again just the backend database that ships with FiftyOne. And then here, I'll define this same backend to use NumPy that I defined in the slide earlier. And again, this is just describing how it'll work when we add it as a backend to similarity index computation. So again, this just created a Python file. And then if I register it with FiftyOne here, we can see that it's now, in this install, is now added to the list of registered backends. And then I could just use it just like any other when I run a method like compute similarity. So it should compute embeddings here, yep, in a second. Again, small data set, doesn't take too long. And then just as before, it creates a view. And this is what, again, based on our logic, it came back up with to find the 10 most similar samples. And I'm actually should mention that I forgot to mention something. I didn't directly say it, but it's actually, I didn't include in the logic the sample we're comparing to. So it actually does in this kind of toy example is it's comparing and computing the 10 most similar samples with respect to the first sample in the data set. So I didn't add the logic to actually specify either a sample or like, natural language to use. It's just saying, hey, what's sample number one? And then what are the samples most similar to it? To me, this, at a first glance, this kind of passes the sniff test. All right, let me that. Again, it seems when I'm in 51 here, it wants my let me scroll back down and hopefully it'll reset here in a second. There we go. All right, let me go back and see and do this. Okay. So again, if we're thinking about kind of the inherent parts of 51, um, the algorithmic backend, so think of 51 brain. If we think about the plugin interface, there's a whole lot that you can do programmatically once you understand the structure behind it. Thankfully, in June 2026, there are kind of a couple cheat codes that we have to kind of make our process a little bit accelerated. Number one is the idea of delegated execution. Again, let me do this here. Delegated execution is something that allows us to take jobs, any type of compute that we've defined using operators, and delegate it to background workers. So this is another abstraction 51 provides. There is what's called delegated operators that you can define in the local 51 app. 51 Enterprise, like the kind of cloud scalable version of 51, includes a more kind of enterprise ready, scalable, robust way of having like permanent GPU clusters that you can delegate a job to. So, for example, if I were in a different instance of 51, like this one here, and I want to say, hey, I want to compute embeddings. Well, if this were a computationally intensive task, I see this schedule here at the bottom. Let me just, and then I can select a GPU orchestrator that 51 is already connected to. And this will run as a background job. And it'll end like while I do other things in the app, it'll be here in this run section that includes like, status, observability, that kind of stuff. Directly within the open source library, it's a little more programmatic. So there isn't the same UI native way as in 51 Enterprise. But if you just Google or look up the 51 kind of delegated orchestration documentation, it'll tell you how on the command line you can, invoke a background job, on your laptop you're running 51 on. So the server itself, that process isn't taken up in the foreground. But ultimately, part of setting up these operators is allowing for this delegated execution so that, again, when you launch an operator, it doesn't have to run in the foreground. It can run as a delegated background job, similar to how it's presented here. All right, give me 1 second here. Give me 1 moment. Okay. So what I showed was a lot of like, code examples that I flipped through. And there is a learning curve, right? Especially when you're trying to understand like the default libraries and Python classes you use and what is the structure of 51.yaml in a plugin. Thankfully, uh, 51 increasingly has a library of skills and MCP support for models and agents and coding harnesses that you can use as part of your enablement and also just to accelerate the work that you do. And uh, the way I want to kind of talk about this is um, as someone who is like constantly learning about 51 myself, right? Even though I, work with the company, um, being able to use skills in a way so that I can abstract away like the underlying code. Like I know how Python works. Like it's just a matter of knowing what classes and methods to call. Really makes my job a lot easier if I like understand the workflow I already want to do. And this is where agents and skills come in, right? It's not meant to like replace you, right? Or it's not meant to like um, you know, undo the need to like understand core computer vision workflows, but it is meant to like take away some of the like mental overhead of needing to know what exactly and how exactly to structure, each and all of these files. So ultimately, plugin operators are callable by an agent through the 51 MCP server. And ultimately, again, if you're not familiar with it, like with how skills and MCP tend to work under the hood, what these are is these are meant to be invocable integrations where rather than needing to supply all the context to your coding agent through like a system prompt or through a conversational prompt, these are tools the agent could use that contain ultimately pre-provided context on how to do things like install a plugin or um, perform operations like compute embeddings and add a data set, or even build a plugin or perform common 51 tasks. So in terms of what 51 supports is, right, the underlying software is the SDK. And then on top of that, we've built our 51 MCP server that has its own tools that your coding agent can call. And then on top of that are what we call skills, which again, in the industry really just refers to packaged prompts of context that can be loaded or called on demand by um, by an agent. And here I use the example of Claude Code because that's what I'm about to show in a moment. But ultimately, it could be Claude Code, it could be Codex, it could be an open source model. As long as it understands how to use like kind of the typical skills packaging and MCP protocol formatting, you're pretty good to go there. So to get started, couple things. If you want to get started with MCP, you can pip install the 51 MCP server. You can also install 51 skills from the plugin marketplace. So in my example here, if I pull up my terminal, I'm going to pull up Claude real quick. Let me share here. Yep. Do I have MCP? I think I have MCP. Yeah, so I have the 51 MCP server, among other things, and that's connected. And then if I also, whoops, sorry, let me get back into here. If I also look at my skills that have loaded, we have all of these 51 skills that I've installed from the plugin marketplace as well. And again, the idea here is these will be naturally invoked by your agent, so it doesn't have to do a whole bunch of other, research from scratch. We've written these to guide the agent through like the proper canonical happy paths that 51 should do. So these can be used and invoked directly and programmatically, using whatever coding agent you like to use. On top of that, more recently, as of the past month, we've also created a UI integration as well. Let me pull up my data set in the UI that I had before. Give me one moment. Give me 1 second here. Do, do, do. All right. So let me do this. So here I have up a subset of the Berkeley Deep Drive dataset. So here's what it normally looks like in 51, right? Here's the sample pane. Here are all the usual metadata filters, delegated operations, panels, and so forth. Up here in the top right, I have this little cube, and this is what we now call 51 agent. And this is, at its surface, a chatbot. But ultimately, what it has access to is it has access to a host of underlying skills that you can enable or disable. Here we have them all enabled by default. Sorry, let me go ahead and reset my view here. Let me, I think that happens when I zoom in and out. There we go. So here we have the 51 agent, and we have all of these skills that are enabled. And then you can then interact with it through natural language, and it'll make the appropriate tool calls that'll also be shown here. So for example, if I go back to the top here, the prompt I gave it was summarize this data set, then create two saved views, one of the 10 blurriest samples and a second saved view of the 10 brightest samples. And we can see here that it made all these tool calls. So it ran the dataset summary tool, it ran count values several times for various criteria. It then created views for brightness and blurriness. It saved the views. And then here it output a summary of the dataset, including class distribution and kind of core balance of attributes. It made some notable observations like, hey, there's some clear class imbalance. It's skewed in terms of the weather and scenes. It's heavily weighted towards clear weather and city level street scenes. And it also created these two views here that calls 10 blurriness and 10 brightness, 10 brightest. And again, part of, so this is what 51 thinks are the 10 blurriest. I don't know if these are actually the blurriest. I'd have to look at the data quality metrics. I don't think it is in this example, actually. Let me look at 10 brightest, see if that passes the sniff test. Oops, sorry, let me reset here. Oh, you know what? This might actually be where the agent food barred me a little bit. Whoops. Let's see what it did. Save view. Oh, that's why. Okay. Interesting. I thought it would have grabbed this blurriness metric, but it looks like that part failed. So whoops. And that's ultimately the case of using LLMs. Let me reset my scene here. Interesting. Okay. So this might actually need to be coached along a little bit here. Let's see. All right. But ultimately, you do get the idea. We see the dataset summary. We can see the skills that were used, and we can see the tool calls. So for example, if I were to type, how would I run or how would I compute embeddings, right? Similar idea, right? It's using Claude here under the hood, but ultimately it has these skills and it would make tool calls to either guide you in the right direction. One thing I also forgot to mention is that if there's an actual operation to perform, it'll pause and give you the option to run it. So hopefully this won't take too long. Let's see. All right. I'll try one more thing. Create a saved view of the first 50 samples. I'm trying to give it something easily that it can do. So it looks like it's telling me how to do it here. So we see set view. There we go. This is what I wanted, right? So ultimately, for an actual operation in the app that requires like read-write capability, here it created this stage, but now it's saying, hey, do you actually want to create the persistent view? And now I'll click review and run, and it'll then invoke the operator and then execute, and then actually create the saved view, which here, it should set here in a minute. See, save view completed. Hopefully, if I refresh, it'll show up. Yeah, there we go. So again, always requires a little bit of like finesse, right? The thing about LLMs is they're non-deterministic by nature, right? So it's often a matter of prompting and that sort of stuff, but it's the sort of thing where I found especially for like some of the very common brain methods, like when working with agents in the terminal, when you aren't necessarily, working with the UI directly in front of you, um, it can be especially helpful just to very, very quickly go through computations and things without needing to like remember exactly, what the structure of the Python object is supposed to be. All right. So again, kind of summarizing here, and hopefully, yeah, screen looks okay. Um, Again, the goal is like, again, if you're familiar with how these tools work, skills and MCP and agents are helpers on top of the tool. Now, again, overall, the idea is they'll get more advanced and can ultimately delegate a lot of the work. So, for example, we're doing some of that today with we have a new feature called agentic labeling that's coming out, where you can train an agent and then it'll run, a state-of-the-art foundation model with a system with a prompt that you provide, say like, hey, find these people that aren't wearing hard hats, for example, and it'll guide the agent towards training for these specific use cases based off like a training set or training samples that you might give it, right? So there's a lot of applications here that are being more and more incorporated into the interface. Okay, so again, that's agents and skills. Again, skills are ultimately just packaged prompts. If you want to install 51 skills, here's the way that you can do it. So again, Claude, this is the example with Claude, but similar idea for other tooling, Claude plugin marketplace add. It's just the 51 skills. It's a public GitHub repo, so you can examine them yourself as well or propose new skills, and then you'll just install 51 skills. And that's basically what caused everything to show up when I ran, /skills in my Claude code a little bit ago. Right. Okay, lastly, just to quickly put a bow on it, when you build plugins, going back to the plugin conversation, again, all it is it's a directory within this plugins directory within by default your 51 directory. So remember though, when you defined that 51 um, .yaml file, that includes things like semantic versioning, right? So it provides a packaging mechanism for you to share your plugins and publish them if needed. Now, the way you can share and install plugins is really straightforward. All you need to do is take that directory that contains your plugin and the 51.yaml manifest and just zip it up. So create a zip file out of it, and then that becomes a shareable artifact. And that's really all you need to do. So once you share it, couple ways that you can share it with a colleague or a user. If it's published as a GitHub release, so let's say you have your plugin published in a GitHub repo. If it's published as a release in that repo, you can invoke the 51 plugins download command. If you just have it available as a local zip file, you can do the same thing. Just call the local zip. You're still running the download command, but again, it installs the local zip file and it'll add that plugin to 51. And then within 51 Enterprise, there is actually like a UI method as well. So if I go to this plugins section here, let me make sure this is shareable. Yes, it is. Okay. Here I'm in the settings panel in 51 inside the enterprise version. We have all these different plugins that you can choose to enable and disable. And if you install a new plugin, it's literally just like, hey, upload the zip file, and then the plugin is installed. So similar idea. right. So that being said, that just about wraps everything up. Couple just key things to mention. Again, the way I wanted to kind of approach this was very much in like the layered discussion, right? So start with kind of your understanding of the core 51 SDK, and then understand that common methods like you use like Brain, for example, include what we call pluggable backends that are just dictionaries, right? The idea being that you can swap in libraries to perform your computational tasks. You're not tied to like the 51 default libraries or backends that get used. And then on top of that, when you actually define a plugin, it includes the plugin manifest, the actual like plugin invocation code and it.py, and then any defined operators and panels that you want to be part of the plugin package. And then lastly, when it comes to just using and extending your use of 51, MCP and skills, using any kind of agent-driven workflows are becoming more and more common. So again, the goal here is to increasingly have those as a part of the platform. If anything, just to allow your core workflows to remain the core workflows and not have to get bogged into like, getting into the weeds of the 51 SDK unless you absolutely have to. There were a couple things in this notebook that were deliberately left as exercises to the reader. So again, you're free to do these on your own. There's one that's just using delegated execution and background workers. There's one which again is going to be dependent on the coding agent you use, but there's an example of using 51 MCP and skills with Claude. And then also there's also just some practice of if you want to package up your plugin and like send it to GitHub and then practice downloading a release and installing it, you can do so here as well. Again, these are just largely meant to be some reference material. But that being said, um, we've just about wrapped up the content here. A few last things as well. These are kind of probably should have like made these different colors or something, but I did want to share a few next steps that I have as QR codes here. First of all, if you want to learn just more about the plugin ecosystem, um, there's those can be found in the 51 docs. We also have an active Discord community that you'll see a lot of Burhan in. But ultimately just the team as well. If you have any questions or you just want to contribute to the 51 project or just want to be part of the community in general, we highly recommend that you join the Discord community. And then on top of that, we have a couple of events coming up. So next week we have an annotation focused event that is really focusing on 51's new annotation features. You can find that on the events page if you'd like to sign up and register. And then yes, best of CVPR. So a couple of weeks ago was the large annual computer vision conference. It's kind of a largely academic, but also industry expo as well. Basically, this event is we've held this for multiple years. It's basically distilling all of the best papers and conference talks at CVPR and kind of having a meetup that goes through those talks. It's in the past, it's been I'm biased, obviously, but I found it to be extremely fun in the past just to get that distillation of like what's the best things going on in computer vision this past year because they tend to show up at CVPR. So we're kind of having a consolidated virtual meetup that talks all about that. And then on top of this as well, you'll receive an email follow-up that contains a recording of this session. It'll contain all of the resources as well. The correct notebook. Again, sorry that we had that issue here at the beginning with it being the wrong notebook, but I'll make sure that corrected one is sent out as well, along with the slides. But that being said, I can see, yeah, any questions about anything we've covered here before we wrap up? Going once, going twice. All right. Well, again, thank you folks for your attendance and participation. Hope to see you at an upcoming event here in the next few weeks. Hope to see you on Discord. Again, it's a great community of folks to just talk about 51 and visual AI in general. Um, Otherwise, again, thanks again. Look out for that follow-up email with the resources and enjoy the rest of your Wednesday. I'll go ahead and close things out from here.